Hello everyone. Last time we talked about the notch signaling pathway in TALL. Today we'll discuss the notch signaling in other hematologic malignancies. It was found that expression level of Notch1 and delta-like 4 were upregulated in the untreated AML patients compared to the controls. A significantly shorter survival in the patients is associated with higher Notch1 and delta-4 expression. The study indicates that notch signaling promotes the development of AML. While some other studies showed different results, it is found that notch signaling is silenced in AML as revealed by absence of expression of non-notch target gene, despite high expression level of Notch2 receptors. Knock-in of ICN1 or ICN2 demonstrate that activation of notch signaling can induce apoptosis of AML blasts. What's more, activation of notch signaling is able to target AML LICs. HERS1 was mediating part of these effects. More works are needed to elucidate the exact role of notch signaling in AML. Studies show that deregulation in the form of hyperactive SHH and went with repressed notch and Hox pathways might act synergistically to form an important hub in CML progression. Combination of HERS1 and BCR-ABL in common myeloid progenitors and granulocyte macrophage progenitors cause acute leukemia resembling blood crisis of CML, suggesting that HERS1 is a key molecule in blood crisis transition in CML. Overexpression or enhanced kinase activity of BCR-ABL and altered expression of Notch1 induces acute leukemia in transgenic model for CML. These studies suggest that Notch might promote the development of CML. Some research identified a novel somatic inactivating Notch pathway mutations in a fraction of patients with chronic myelomonocytic leukemia. Further studies showed that around 12% of CMML patients harbored inactivating mutations in NCSTM, MOMO1, Alpha-1A, and Notch2. Inactivation of notch signaling in mouse hematopoietic stem cells results in an aberrant accumulation of granulocyte or monocyte progenitors, extramedullary hematopoiesis, and the induction of CMML-like disease, which indicates that notch signaling might also play a role in CMML. Except TALL, notch signaling might also take part in other T-cell malignancies. Notch1 and JAK1 are overexpressed in T-cell-derived anaplastic large cell lymphoma, we call it ALCL, cells, compared to normal reactive tissue. Induced HERS1 expression is accompanied by enhanced proliferation rates and reduced sensitivity to arsenide-induced apoptosis of ALCL cells. Activating Notch1 mutations are also found in CLL, and the mutations predicted to impair FBW-induced Notch1 degradation. The overall frequency of Notch1 mutations was from 8.3% to 12.2%. The majority of CLL patients harbor the same free-shift mutations. Notch1 mutations are associated with poor prognosis in CLL and appear to define a distinct high-risk clinical subtype. There is a definite role of Notch signaling in multiple myeloma. Notch signaling is activated due to interaction among nearby myeloma cells or to the engagement of Notch receptors by ligands expressed on the surrounding stroma cells. The activation of Notch signaling promotes the proliferation of tumor cells through SDF1 alpha, JAK1 or JAK2 in multiple myeloma cells, increases the release of soluble factors including interleukin-6, vascular endothelial growth factor, we call it a VEGF, and also insulin-like growth factor 1, we call it a IGF-1, from BMSCs. And the released factors have a recognized promoting activity for multiple myeloma. High Notch signaling in multiple myeloma cells stimulates the release of major osteoclastogenic soluble factor, RUNCL. Multiple myeloma cell-derived Notch ligands activates Notch signaling in surrounding BMSCs, boosting the secretion of RUNCL. RUNCL engages RUNC on OCL progenitor, thereby activating the osteoclastogenic F-kappa-B pathway, which in turn stimulates the osteoclastogenic Notch signaling by promoting Notch2 expression. Multiple myeloma cell-derived JAK ligand further boost Notch signaling in OCL progenitors by engaging Notch2. There are many studies about alterations of Notch pathway in multiple myeloma seen in the diagram. We can conclude that Notch is deregulated in many hematologic malignancies. Next time, we'll discuss whether Notch can be a therapeutic target. Thank you.